Practice solving one variable linear equations. One variable linear equations are important enough that we have to be 100% on them to go throughout the school year. Remember, our basic strategy is to usually simplify before solving. So we're just starting with distributing usually, then combining like terms, then solving. You want all copies of the variable on the same side of the equal sign. It's rare that we're going to multiply or divide by a variable, and you need to know that your inverse operations, when there's addition or a positive constant, we'll get rid of that with subtraction. If there's a negative constant or subtraction, we'll usually get rid of that with addition. Multiplication and division are also opposites. Okay, so distributive property comes first. We distribute. On the left side, there's nothing to distribute on the right, so we get 3x plus 12 equals 3x plus 11. We want to get all the variables on the same side, so that involves subtracting the variables from both sides since they're already simplified. Subtract 3x from both sides, and we get 12 equals 11. That's never true. No solution. If you get something that's never true, you say that it's no solution because this is a false statement. 12 is never equal to 11, so we say it's no solution. Usually we'll say x equals 7 or x equals 12, but if we get something where there's no variable and the numbers are not equal, we say it's no solution. Okay. Now, distributive property. There's multiple distributive properties here. The y plus 7 remains unchanged. Remember, the distributive property says to multiply 4y, 8, 3y, 15, 2y, and negative 16. If you're stuck on distributive property, go back to the video on distributive property. If you're stuck on combining like terms, go back to the video on combining like terms. Now, when we're combining like terms, we're only combining like terms on the same side of the equal sign, so I'm going to use different symbols for the like terms on different sides of the equal sign. I don't want people thinking that we're combining like terms that are on opposite sides. So this is 1y plus 4y is 5y's. This is positive 7 minus 8 is negative 1. We have positive 3y, positive 2y is 5y, and positive 15 minus 16 is negative 1. Ooh, these are definitely the same. These are always true. This is just a true equation. If you got rid of the variables, you'd get negative 1 equals negative 1, which is still a true equation. It's always the same. So this means that the original equation was always true. So we can say that all real numbers make it true. Any number, if you plug it into the original equation, will make it true because it doesn't matter what y was. No matter what, it'll be the same y on both sides, and because they're valued the same, they will give you the same result on the left and the right. That's not usually the case, but these are two special cases of solving. Not all of these are going to turn out that way. All right, no distributive property. Let's combine like terms. Here are like terms. Here are like terms. Here are like terms. Here are like terms. So we're looking for the same variable. So we're doing 1 plus 2 is 3x. 3 plus 4 is 7. 5x plus 6x is 11x. And 7 plus 8 is 15. Please remember you can't combine across the equal sign. That would not be simplifying. Now we can get rid of the variables on either side. I'm going to get rid of this variable because it's a positive 3x. I'm subtracting 3x, getting 8x. Now get rid of the constant on the same side as the variable, leaving us with negative 8 equals 8x. Last step is this is 8 times x, so we'll divide by 8, and negative 8 divided by 8 is negative 1. Yay. Here. Let's go through how we can get rid of fractions. So this is 1/4 x minus 3/4. Distributing this in, this is 2x. 2 times 5/6 is 10/6, or 5/3. 2 divided by 6 is 1 divided by 3, plus 3x. Now, if you want to, you can keep going through the same steps that we've always done with the fractions. Or, another way is to multiply the entire equation by the product of any, or the lowest common multiple of the denominator. So 4 times 3, the lowest common multiple of these is 12. 12 is a multiple of 4, and it's a multiple of 3, and it's a multiple of 4. So 12 times 1/4 will give us 3. 12 times 3/4 gives us -9. 12 times 2 gives us 24. 12 times 5/3, so this is technically distributing on both sides. Really what I'm doing is I'm multiplying by 12. If I wanted to be really careful, what I'd do is I'd say, okay, I'm multiplying by 12 on this side and multiplying by 12 on this side, and they're not extending across the equal sign. That's technically what's happening. But usually we shorthand it. 12 times 5/3 is 20, and 12 times 3x is 36x. Now we can combine like terms on the same side of the equal sign. The only like terms on the same side are 24x and 36x, giving us 50x. I'm sorry, 60x. And no other like terms, 3x minus 9. Now we want to get all the variables on the same side. Subtract 3x to get 57x plus 20 equals, please be careful, that negative is attached to the 9, not to the 3. That's why we subtracted 3, even though this was subtraction. It was a positive 3x, so we subtracted. Minus 20, minus 20, negative 29 equals 57x. Last step, this is 57 times x. And this is why I really recommend using fractions. If you wanted to do decimals, go for it. Go ahead and divide negative 29 by 57. But this is a perfectly fine answer if you're fine with fractions. Okay, subtracting 8x from both sides. There's nothing to simplify on either side. So we get negative 1/6 equals positive 1/6. No solution. Remember, this is subtraction because this is a positive 8x. Distributive property. Start with distributing in any coefficients to parentheses. So 4t minus 28 minus 3t equals -7 plus t. Really important to see that plus. Combining like terms, we have 4t and -3t. That adds to positive 1t. Minus 28 equals -7 plus t. Now we can subtract t from both sides, and we get -28 equals -7. So that has no solution. 331 students went on a field trip. 6 buses were filled, and 7 students traveled in cars. So we know that the buses were filled. So 6 buses were filled. We don't know how many people were in each bus. That's what we're asked for, how many students were in each bus. So we can say 6 times the number of students in each bus, plus the 7 students who travel in cars is a total of 331 students. Now we can solve this equation. Subtract 7 from both sides. 6x equals 324. Divide by 6 on both sides. X equals 54. So 54 students in each bus. Suma Lee won 40 super bouncing balls playing horseshoes at her school's game night. She gave 2 to each of her friends. So she had 40. She gave 2 to each of her friends and had 8 remaining. How many friends does she have? Now some of you might have thought, okay, let me just subtract 8 from 40 and then divide that number by how many by 2 to figure out how many friends she has. Well, that's really what the equation tells you to do. Say she has 16 friends. 16 times 2 is 32, plus 8 is 40. To mail a first-class letter, the U.S. Postal Service charges 34 cents. This is old. For the first ounce and 21 cents for each additional ounce. So 34 cents for the first ounce and 21 cents for each ounce beyond the first one. Additional ounce. So if there were 7 ounces, you'd do 7 minus 1 and say 6 additional ounces. So it's the number of ounces minus 1. So I'm going to put that here, the number of ounces minus 1, in order to describe each additional ounce. It costs $1.18 to mail your letter. How many ounces does it weigh? Well, we can subtract 34 cents. And that says $0.21 times x minus 1 equals, let's see, 8 minus 4 is 4. 11 minus 3 is 8. Now, let's distribute 0.21x minus 0.21 equals 0.84. Add 21 hundredths to both sides. So 21 hundredths equals $1.05. Dividing, that x disappeared. I see that happen all the time with students, and the same thing sometimes happens with us teachers. But the key is that I check my work as I'm going through it, usually line by line rather than starting from the beginning every time. And it's much easier to check your work as you go rather than all at the end. All right, so it cost 5 ounces. Thank you.